All right, so we've been talking about functions and what is a function. Graphs are one of the most powerful ways of visualizing a function's rule because you can quickly read the outputs of the given inputs. Then you can easily see features such as the minimum and the maximum of their values. So, given the function y equals f of x defined by this graph below, answer the following questions. So, f of 4. We need to find where x is 4. Well, where x is 4, y is 1. And where x is negative 1, y is 1, 2, 3, 4, 5, positive 6. So for what values of x does f of x equal negative 2? So we need to find on the y-axis where there's negative 2, there are two values for x there. And it's when x is positive 1 and when x is positive 3. So that is the solution set for f of x equals negative 2. State the minimum and maximum values of the function. So we're looking at minimum is the lowest. These are for y values. We want to know for y. So where is the minimum? So the minimum is right here. So the minimum is y equals negative 3. And then we need to look at the maximum. So the highest that this one goes. You'll notice that the graph doesn't have arrows on the ends, so that means as high as it goes. And as high as it goes, so the maximum is y equals positive 6. So if we can read a graph to produce outputs or y values if we are given inputs of x values, then we should be able to reverse the process and produce a graph of it with its algebraically expressed rule. So consider the function. We're going to fill out the table for the given inputs. So we're going to put the given x values in. So 2 times negative 2 plus 3, 2 times negative 1 plus 3, 2 times 0 plus 3, 2 times 1 plus 3, 2 times 2 plus 3, and 2 times 3 plus 3. So 2 times negative 3 is negative 6 plus 3, which will give us, when x is negative 3, y is also negative 3. Then I have negative 4 plus 3, so when x is negative 2, y is negative 1. And when x is negative 1, y is 1. 0 plus 3, so when x is 0, y is 3. 2 plus 3, so when x is 1, y is 5. 4 plus 3, so when x is 2, y is 7. 6 plus 3, so when x is 3, y is 9. So we're going to draw a graph of the functions on the axis provided. So when x is negative 3, y is negative 3. When x is negative 2, y is negative 1, and so on. If you were to plot all of those points, you'll notice what I did was I went up by 2 every single time because our y's go up by 2 every single time. So we need to never forget that all we need to do to translate between an equation and a graph is to plot input or output pairs according to whatever rule we're given. So let's look at a nonlinear function. Remember that nonlinear means it will not be a straight line. So we have a quadratic function where for every x we're going to square. So negative 3 squared is positive 9. So negative 3, positive 9. Negative 2 squared is positive 4. So negative 2, positive 4. Negative 1 squared is positive 1. So negative 1, 1. 0 squared is always just going to be 0. Positive 1 squared is 1. Positive 2 squared is 4. And positive 3 squared is 9. So we're going to plot these points. So negative 3, positive 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Then negative 2, positive 4. Then negative 1, 1, and 0, 0. You will notice that when you plot the points on the other side, that they are symmetrical. And finally, consider this function. So there's a few different pieces to this. There are 2 different parts to it, and we're going to have to evaluate it. So the first thing we need to look at is f of 4. So we have when x is less than 0, we use the top equation, and when x is more than or equal to 0, we use the bottom equation. So x, the 4, is more than 0, so we do 6 minus x. So we do 6 minus 4, which equals 2. But then we look at the other equation where x is less than 1, and notice that x is less than 1 here. Negative 3 is less than 1. So we do 2 times negative 3 plus 6. So negative 6 plus 6 equals 0. So we need to keep in mind which one we use. We just found that negative 3, we use the 2x plus 6, so negative 3, 0. And now we need to go through and decide which equation do we use. Well, this is still less than 0. This is still less than 0. But remember, the other one is when x is more than or equal to 0. So we do 6 minus x, 6 minus x, 6 minus x, 6 minus x. So 2 times negative 2 plus 6. So when x is negative 2, y is 2, because negative 2 times 2 is 4, negative 4. Negative 4 plus 6 is positive 2. All right, 2 times negative 1 plus 6. So when x is negative 1, y is 4. The other ones, we're just going to plug x in. So when x is 0, y is 6. When x is 1, y is 5. When x is 2, y is 4. And when x is 3, y is 3. So we're going to plot these points. Negative 3, 0. Negative 2, 2. And negative 1, 4. But then we have 0, 6, 1, 5, 2, 4, 3, 3. What we have done here is we have created a nonlinear function.